Hello class, this is the third video covering activity 3.7. We had just finished up problems 16, 17, and 18 in the previous video, where we were in exponential form and we were asked to rewrite using logs or change to logarithmic form. So notice all of my answers have a log in them. Now we start with log and we're asked to write an answer using exponents. So if you look at problem 19, the base of my log, well, if nothing's written underneath it, we can assume this is base 10. So I'm going to write my base of my exponent is a 10, the exponent is a 1, and that equals 10. And then we know 10 to the 1 equals 10. I'm going to change my pen color. Okay, so if you look at number 20, the base of my log is 10, right? Again, if nothing's written underneath the log, we assume it's a 10. The exponent is the -2, right? That's my exponent. And the 0.01 is on the outside. And again, you can always double check to see if you've done this correctly with your calculator. So I want to verify that 10 raised to the -2 indeed equals this 0.01. And it does, right? All right, let's look at number 21. Okay, so again, the base of my log is 10 because nothing's written underneath my log. So I'll write 10. And the exponent is the -1. And that equals 1 over 10. Right? And again, remember, if we add 10 to the 1, we know that answer is 10. So 10 to the -1 would be 1 over 10, right? We learned that in exponents, which was covered in chapter 2. Okay, the last two problems. All right, natural log. Again, if I have an ln, it's assumed we're in base e. So the base of my exponent would be the e. The exponent would be the 2. And we're going to say that equals e to the 2. And that makes sense, right? E to the 2 equals e to the 2. Right? And number 23, if nothing's written underneath the ln, we write an e. The exponent is the 0, and that's going to equal 1. And we know that anything raised to the 0 is indeed 1. Okay? Next section, it says, all right, evaluate logs by changing to exponential form. So take a look at their example. We have log base 7 of 49. Can we rewrite that using the properties of exponents? So if I don't know what log base 7 of 49 is, I can set that equal to x. And then we can rewrite this as 7 to the x equals 49. Right? Similar to what we've done up here. Right? If we have something that's written in logarithmic form, right, we can write 10 to the -2 equals 0.001. So here, we have the base is 7. So the base of my exponent is 7. The exponent is the x. And that's going to equal 49. Now you can ask yourself, well, what number raised to the x will give me 49? Well, 7 to the 2 gives me 49. So the value of x equals 2. And this would be your final answer. Right? If I were to say, what is the answer to log base 7 of 49? You'd say the answer is 2. All right, so let's practice a few of these. So when I look at 24, I don't know the answer, so I'll say, okay, this equals x. And then I could say 2 raised to the x equals 32. Now, what number is going to make that true? 2 raised to what number would give me 32? The answer is 5. Okay, so if I said, what is the answer to log base 2 of 32? You'd say, Mike, the answer is 5. Let's give ourselves a little more space. Okay, so 27, there's nothing written underneath the log, so this is really going to be 10, right, raised to the x equals 100. So the answer would have to be 2, right, because 10 times 10 is 2. When I look at 28, right, we'll say, all right, this is equal to x. So we have 10 raised to the x equals 1,000. Well, what value of x would make this true? Well, 10 times 10 is 100. 100 times 10 is 1,000. So it'd have to be 3. right? 10 cubed equals 1,000. 29, now we introduce the natural log. Okay, well, the base of the natural log is e, whoops, excuse me. Got a little ahead of myself. So the base of the natural log is e, this thing equals x. So think of this as e to the x equals e squared, right? Because there's an e down here. All right, so the only thing that would make this true would be e to the 2 equals e to the 2, right? So the value of x that would make this thing true would have to be the 2, right? Number 30, you could think of this as e to the x equals 1. The only thing that would make that true would be 0, right? E to the 0 equals 1. Number 31, well, now we're back to log, right? So you might say, well, when do we use e and when do we use log? We use e if I see ln. We use the 10 if I see log. Right, so this would be 10 to the x equals 0.001. Right? Let's make that an x there. Right? We don't know what this equals, so we'll call it x. All right, so now we have to think about this one. All right, so if I said 10 to the 3 equals 1,000, right, that makes sense, but we're looking for 1 over 1,000. So it has to be 10 to the negative 3 equals 1 over 1,000, which equals 0.001. Right, so the answer to make this thing true would have to be negative 3. Negative 3 is my answer, right? So log base 10 of 0.001 equals negative 3. And by the way, we can check this in our calculator, right? If I were to actually enter, right, this log and then put in 0.001 and then press enter, I get negative 3, right? Which is what we've done by hand. So your second test will have 2 parts, calculator and a non-calculator part. Perhaps I could ask you to do these problems without using your calculator. Question 32, right? We'd say 4 to the x equals 16. Right? Remember, there's an equals x out here. What value of x makes that true? It's going to be 2, right? Because 4 times 4 is 16. And then the last one, we have 3 to the x equals 3. The only thing that could make that true would be 1, right? 3 raised to the 1 equals 3. Okay, so let's keep going. The next set of problems has you evaluate logs using your calculator. So when I look at practice problems 34 to 38, there's really not much to do here, to be honest with you. If we take our calculator, it says evaluate each logarithm using your calculator round to 4 decimal places. So 34, you would simply just press log and 12 and then enter. Right? So, if you're going to write this out to 4 decimal places, right, I'd write 1.07912. So maybe I'll just type that in. Oops. Right, so 1.07992, that's 4 decimal places, right? And that matches what I had in my calculator. And number 35, right, again, there's not really much to do here. You're just going to type it exactly as you see it. So number 35 would be 1.9031, and so on. Right, it would look something like this. I don't know, maybe 36 would be tricky because there's a fraction. So you type in log, and then I would just write 3 divided by 4 and press enter. You could also put in 0.75, and you get negative 0.1249. All right, so as you can see, there's really not much to do for these problems. All right, so we'll move on. In fact, I think I want to stop here, and then I'll post another video to finish up this section 3.7.